Welcome to the Good Chemistry Podcast. I'm Nick Jikomis, and today we have a bonus episode, the first bonus episode of the podcast. This was a serendipitous finding that was shared with me by a former podcast guest, John Page. He actually found an old tape, probably from the 1980s, of a lecture that Michael Beug gave in Washington, most likely, all about psilocybe mushrooms of the Pacific Northwest and his chemical analysis of the psilocybin and psilocin content of those mushrooms. Michael Beug was a professor, is a retired professor now in Washington. He was a mycology professor for decades, I believe, and is a world expert on psilocybe mushrooms. This lecture is about 25 minutes long. It has reasonable audio quality, but it's got some fairly interesting information if you're interested in mycology and psilocybe mushrooms. Michael walks through the psilocybin and psilocin content of various species of psilocybin mushrooms native to the Pacific Northwest and talks about some of the key differences they found between species. As always, if you want to support the podcast, please like, share, or subscribe, either by becoming a patron on Patreon or by subscribing on YouTube. And with that, here's a bonus lecture by Professor Michael Beug.
I've been collecting and analyzing psilocybes and related species for a little over 4 years now, and gathering that data together. And I think I will first present you with a synopsis of the data and some of the things that I found in getting to it. And then I'll have a break, and those of you that want to hear about how it's done chemically can, but those of you that just want the hard data, I'll give that first, so you don't have to listen to the chemistry part. To date, I have analyzed a little over 20 species of mushrooms from the Pacific Northwest from 7 different genera. What we've done is selected, first of all of the psilocybes that we could find and analyzed those. Then we've analyzed all of the mushrooms that anybody has brought in and said, oh boy, this is a great hallucinogenic species. And then we've looked at everything that stains blue, and that's everything from a bolete to a mycena to a Hygrophorus conicus. And we've looked at virtually all the pinealid species in the Pacific Northwest, including those that have been transferred to Paniolina and Saptorella. And I've looked at virtually all of the Conosidae species of the Pacific Northwest. And in that survey, we have turned up psilocybin and or psilocin in roughly a third of the species of psilocybe that we've looked at, 2 species of pinealid, and 2 species of Conosidae. Among the psilocybes, the most stable mushroom, the one that we find the most consistent amounts, and also one of the most potent, is Psilocybe semilanciata. In that mushroom, you will find quantities of psilocybin ranging from roughly 5 to 6 milligrams per gram dry weight, up to 15 milligrams per gram dry weight. As psilocybes go, that turns out to be a fairly narrow range of potency. If I was having a few drinks, though, I would be nervous about a mushroom that varied that much. It seems to me it's a lot of difference between 2 drinks and 4 drinks. And you're really talking there about a 3-fold difference in levels from one collection to another with Psilocybe semilanciata. And that's the most stable one we've found. And I found that on Psilocybe semilanciata, it didn't seem to matter too much how it was taken care of. It contains psilocybin only. It doesn't contain any psilocin at all, at least not that I can detect. And with the equipment I have, I can detect less than 1/100th of a milligram per gram. And you're not interested until the levels are over 1 milligram per gram. So we could say for all practical purposes it has no psilocin. There may be a trace there. I've also found that Psilocybe semilanceata, whether it's freeze-dried or air-dried, I get about the same result if I split a collection. And I also find that if I extract it and analyze it immediately, I get pretty much the same result as if I extract it and analyze it a year after I've collected it. And whether I've stored it in the freezer or not. And that makes semilanceata very unusual among the psilocybes, because many others, it makes a great difference how you take care of them after you pick them, and also how you store them. Yes? There was a question whether I find a different potency between fresh and dry. And with Psilocybe semilanceata, I don't see any decrease in activity. Now, if you're looking at potency per gram, there's an obvious difference because the things are about 90% water. And everything I'm going to be talking about today is based on dry weight. Because if you base it on fresh weight, it really depends on how wet the mushroom is. You can't get any reasonable dosage on fresh mushrooms because their actual moisture content is just variable enough. So I dry everything first, and for analysis I freeze dry it, because on some species you get significant losses of psilocybin and psilocin if you just plain dry them. Well, first you shell out $10,000 for a lyophilizer, and lacking that, it can be. Oh, well, if you've got a frost-free freezer, you can, in essence, freeze-dry slowly. The problem is a frost-free freezer, you have temperature cycles, and with some species, I haven't experimented. I don't know whether you would get any loss in a freeze. The other thing you can do is you can put them in a freezer and just let them sit for a year, and the thin-flesh species, that's all but Psilocybe cubensis, will be dry within a year, because what happens whenever you freeze something, water has a significant vapor pressure when it's frozen, it sublimes away. So you're really subliming the water in a freeze dryer. The difference is in a freeze dryer, I freeze down to minus 150 degrees, and then I pump on it with a high vacuum. And that strips it out within a matter of a couple of hours. At that low, it doesn't make any difference between Fahrenheit and Celsius. I mean, give or take 30 degrees is a moot point. Yes. Well, out here we have Gymnopolis ventricosus, which we thought was spectabular up until a brief time ago when Alex straightened this out, and I have analyzed several collections of Gymnopolis ventricosus, and Gymnopolis ventricosus is inactive completely. And I've never yet gotten my hands on anything that I know for sure is spectabular. They are exact lookalikes. Oh, inactivity. I find there are species of Penelus, and I'll mention them as I come through, that if I don't process with extreme rapidity, I don't find anything in them. And so there's two things I want to emphasize with fresh collection and extremely rapid analysis, I get a lot of variability. Okay. With some species, and I started with Psilocybe specifically, it doesn't seem to make a great deal of difference how I process it. I get a very similar answer. I mean, give or take a factor of 3. I mean, that's good for psilocybes to come that close. But I don't know about Spectabilis because I've never been able to work with it. So I don't know how sensitive it is to the drying procedure and the storage procedure. Well, it depends. Okay, it depends on whether the mushroom... Let me go through some more of the data, and I think some of this will come out. I'll answer your question, and then we can come back to some specifics. But it depends literally on how much psilocin is in the mushroom versus psilocybin. It also depends to a degree, I believe, on some enzymatic activity, but the enzymes aren't identified. But psilocin is quite unstable to heat. So the colder you keep it, it's also unstable in aqueous solution. That is, when you get it dissolved in water. So psilocin is going to decompose fairly quickly. And once you've broken the cell structures and you let it sit around in aqueous solution, your psilocin isn't going to be there. And again, it depends on the species. The longest I've ever been able to keep it around in aqueous solution is about a week. But if you cook your mushrooms up to make tea, for example, when you get it that hot, psilocybin is the phosphorylated analog of psilocin. And psilocybin simply dephosphorylates and turns into psilocin, which decomposes. So you heat these things up, and if there's much moisture around, you're not going to have either psilocybin or psilocin around very long. Depends on the mushroom, and I really want to emphasize that. I can't tell you that you can get away with quite a bit with Psilocybe. With a two-spored Panilis that we haven't named yet, that we'll be naming this fall, that grows in a couple areas in the Pacific Northwest, you can get away, an hour or two. If it takes you any longer than that, you can forget it. You won't find anything in the mushroom. I wouldn't make tea if I don't use these mushrooms. I just analyze them. But based on what I know of their chemistry, I wouldn't make tea from them. I'd make a smoothie or something if I was going to use it. Well, in case your attention wanes or you go to sleep, I'll get to the next most interesting mushroom second. And that's Psilocybe cyanescens. If you're gonna talk about a mushroom that's going to do a good nasty job on you or whatever it is, that's cyanescens. And that little beggar can have anywhere from 1 milligram of psilocin up to about 11 milligrams of psilocin, and it always has more psilocybin than psilocin. That's another thing I just noticed in analyzing about 15 or 20 collections of cyanescens. But I have found that with as much as 13, 14 milligrams of psilocybin per gram dry weight. Now, that seems like you're going to get a good heavy dose, but again, if you're finding some that's not very potent, you decide on a number of grams that gives you a good dose, and then you get into one of these real wallopers, it can be a pretty good surprise, because my collections of Psilocybe cyanescens vary over more than an order of magnitude. See, we were talking about a factor of 3 in Semilanciata. Now we're talking about a factor of 10 in potency from time to time. You know, setting is obviously important, but dosage, when you're talking about that kind of a range, is going to have a little bit of an effect as well. I'll get to cultivated ones shortly, okay? And I'm only going to talk about cubensis. I mean, let's not waste our time cultivating these things that are hard to cultivate. I mean, you go blue in the face cultivating cyanescens, you'll get a fruiting body once in a while, but that thing grows wild in abundance, so you don't cultivate it. But what I have done with cyanescens is staked out a patch and gone down back to the patch time after time after time. Whose backyard should I tell about? I mean, if you want cyanescens in your yard, just ship in a bunch of quote-unquote beauty bark. That's ground bark, and beauty bark seems to be a good productive brand. And if that doesn't work for you within one season, obtain some cyanescens from someone and waste a few caps around your beauty bark, and you'll have a good crop going. And it grows for years and years once it gets started. There's a woman in Bellevue, but I don't think she'd like it. She was getting a little upset at the lines. Cars were sometimes from here to the end of the building down there, you know, and people pouring through her beauty bark patch. But cyanescens grows from Vancouver, the city of Vancouver, south at least to Portland. Don't go east very far, however. As soon as you cross the mountains, you're out of luck.
From the same patch that you've been going back to, what variation in potency do you find from the same patch?
Oh, from the same patch, there's only about an 8-fold variation.
Thank you.
Okay. It only works west of the Cascades, and it begins to fail you when you get down into California, but that's the local. If you just go to your nursery and say you would like a truckload of beauty bark, it's $4.50 or thereabouts per cubic yard, and they just drive up and dump it, you spread it, and there's one bonus on that, by the way, is if you're lucky, you frequently will get a big crop of morels in the spring, you see. So there's more reasons to buy this beauty bark than just cyanescens. In fact, I'd say myself that there's a better reason. That's that crop of morels, but that's a matter of opinion, of course. And I think I'm outnumbered today. Well, I'm getting to Beocistus. I mean, it's not just cyanescens that comes up in the beauty bark, which is the point. And Beocistus also fruits in the beauty bark. Most people I know seem to get bigger crops of cyanescens. And, well, we'll move on to Beocistus now. I think we've... Beocistus tends to be a little bit more consistent in level, but it also runs a lot lower. I mean, I typically find that its concentration of psilocybin is 2.0 plus or minus 1.5 milligrams per gram by dry weight. And psilocin turns out to be about 1.9 plus or minus 1.5 milligrams per gram dry weight. The highest I've encountered is 8 milligrams psilocybin along with 3 milligrams psilocin per gram dry weight. So it typically comes in quite a bit lower than semilanciata and quite a bit lower than your typical cyanescence. But again, there's a six-fold variation. And I have found it down near zero. Beocystis has been researched much more carefully by other workers that are here in the audience, and so I haven't done careful drying studies with it and careful studies of how it changes year to year, because that's already been published and it's in the literature. But it's a much weaker mushroom than most people presume. I was always told that it's much more potent than cyanescence, for example.
What about the other activities like
Well, you said the other active ingredients. I'll talk about the other ingredients until I see those materials in pure form and hear that they've been fed to somebody and know what happens. I'm not going to comment on their activity. Does anyone here know of anybody that's ever been fed extracted Beocystin? We've never been able to make it. I've been trying to make it for 3 years now. Beocystin nor Beocystin, it's a little bit nasty. It's not cooperative. You can synthesize psilocybin and psilocin. It isn't easy and it isn't worth it. But I haven't found anyone yet who can synthesize Beocystin. I haven't done it myself. I let my students do that kind of work. Well, Beocystin isn't the only compound that has a lot of other peaks showing up in the chromatogram that could be other indoles. Specifically, Beocystin isn't the mushroom that I find the greatest amount of the peak that has been attributed to Beocystis. Okay? Beocystin, I mean. So, when I analyze Psilocybe beocystis, I get a peak on my chromatograms corresponding to Beocystin. But a lot of the other species give me a bigger peak at that point. And in fact, in Beocystis itself, the Beocystin peak is often not detectable. So I wouldn't even say that it's the highest in Beocystin, but what I'm hedging on is just because I get a peak in a certain point, I've got to have other corroboration before I say it's Beocystin. And I have other corroboration for psilocybin and psilocin. And I'm just sort of waiting. There's a lot of work to be done on these mushrooms yet. In Psilocybe beocystis, for example, I can isolate 12 peaks that give me a reaction with my Ehrlich's reagent, and Ehrlich's is generally specific for psilocybin, psilocin, and related compounds. So obviously there's some other things in there, but until somebody gets them out, isolates them, gets them in quantity, and then tests them, I don't know what the other peaks are. But cyanescence also has a dozen or more things in it. And for example, semilanciata's got a huge amount of some very interesting compound in it. It's not psilocybin, it's not psilocin. I have no idea what it is, but it's loaded with whatever that thing is. And it reacts very nicely with my spray reagents, but I don't know. So you can speculate all over the map, but most people who've had a lot of experience conclude that cyanescence is indeed more potent than Beocystis at this point. Okay, so then there's Psilocybe pelliculosa. That's a thing that looks an awful lot like semilanciata in the field. It doesn't have that pronounced nipple, and it's a woodland species rather than a meadow and grassland species. And Psilocybe folliculosa is much the same chemically as Psilocybe semilanceata. So the general structural similarity seems to be carried over in the chemistry. And then there's Dr. Guzman, what was that? Psilocybe americana variety, liniformans. Is that the one we just named?
Liniformans variety there.
Oh, liniformans. I came close. I should pay more attention to these papers, I guess. Which if I got my name on them. But liniformans variety americana is also somewhat similar in habitat and stature to semilanceata. I'm certain that people who are picking semilanceata pick it accidentally and consume it. And it has the same chemistry. Its chromatograms look almost identical to semilanceata. So the liniformans variety americana is very similar to Psilocybe semilanceata. Well, there are morphological and microscopic differences. The cap is broader and smoother, and it doesn't have the little nipple on the top. And I don't own Kodachromes of that one. And it's interesting how these parallels do occur, because the other mushroom that we named in that paper, Psilocybe cyanophrygolosa, looks a lot like Psilocybe baecistus, except that it isn't wavy around the margin. It's much more smooth around the margin. And the people that were involved in pointing that mushroom out to me are here, and I'm not going to name them because then they'll probably get inundated with people looking for where to find the mushroom. But they brought collections of that to the attention of me and Paul Stamets over a period of several years, and we finally got around to identifying and naming it.